So let's talk about creating partition tables. SQL Server 2012 includes the T-SQL extensions to allow for partition tables and indexes. When you want to create a partition table, you have to complete the following tasks. First, we have to decide what the partition key will be. Then we have to create a partition function, map that to a partition scheme, and then create a table to identify the partition scheme it should use. So some key terms. Partition key, the column in a table whose values determine which partition the data resides. The partition function is a function that specifies how to partition the table by defining key boundaries for each subset of data. And the partition scheme will map the individual partitions to one or more file groups. So once we select a partition key, the next step is to define the partitions. The create partition function specifies how to divide the table by identifying those boundaries for each partition. The basic syntax for the create partition function is as follows. Create partition function will give the partition function a name, will indicate the data type. It's called the input parameter type. We'll discuss that in a little bit. And we'll define that as whether it is a range left or right for particular boundary values. So let's take a look at this in greater detail. The input parameter type specifies the data type of the partition key. It's not the name of the partitioning column. Left and right keywords specify which side of a partition boundary the boundary value belongs. Left is the default, and it's used if you don't explicitly state it. A partition function defined as using left boundaries indicates that the boundary value will exist in the partition to the values left. Obviously, right boundaries place values in the partition to the values right. All partition key values need to map to a partition. That's something you need to remember. It's really important that the entire domain of values have to map to a partition. SQL Server actually will create n+1 partitions for every partition function. Let's take a look at some examples. Here you can see we have a partition function that we're going to use. We're doing a range left at the top here and a range right down at the bottom. The only difference in the syntax is the word left and right. Notice that the functions both only specify 4 boundary values. They both specify 100, 1,000, 10,000, and 100,000. But you need to be aware and be careful here. Values less than the minimum and greater than the maximum, they're part of the entire domain of values, right? We do have numbers that exist that are less than 100 and greater than 100,000, and we have to account for those. They must map to a partition. So here are the details. Here you can see the values that will fall into the partitions based on how we defined it as either range left or range right. And the interesting things to look at here, as I mentioned, is that all of the values within the domain have to map to something. So the key things to look at here is the first row and row number 5. In row 1, we see that values less than or equal to 100 are taken care of. And in row 5, we see that those greater than 100,000 are taken care of. So again, numbers not specifically set as boundary values are actually mapping to specific partitions. Now here's a tip that you should pay attention to. If there's a need to specify minimum or maximum values, make sure that you apply a check constraint on the table. That way the table will reject anything that's inappropriate. So for example, if we wanted to prevent partition key values greater than 100,000, we would define our function using range left and place a check constraint on the table to reject those values that were greater than 100,000. In addition, placing a check constraint on the table effectively leaves either the left or rightmost partition empty. And as you'll see, that becomes a benefit for modifying partitions later. Now, believe it or not, SQL Server actually allows the partition key column to contain null values. But it uses some strange rules when dealing with these values. By default, all records having a partition key value of null exist on the leftmost partition. And if a partition function defined using range right contains a null boundary, the leftmost partition remains empty and rows containing null values exist on the next partition. So it really gets a little squirrely. You have to remember the rules. Now I want to take some time to talk about date-time values, specifically if you're going to use them as your partition key. Date-time values can present some interesting challenges. The data type actually contains the date and the time value, the time portion being what developers often forget. You'll see this most often in legacy systems, but let's go through it here so that you understand the process. For example, SQL Server will interpret the date-time value of January 1st, 2007 as actually having the time portion midnight, all zeros. This is subtle, but it's enough for you to express caution with respect to partition functions. Let's see why. Consider the following. Take a look at this partition function that we're going to define. We're going to define it range left, and we're going to place the boundary values as January 1st, 2007 and July 1st, 2007. Because we defined it using left, and the boundaries that do not contain specific time values, which we can see in the example, SQL will use the default midnight as the time portion. So any rows with a partition key value of midnight, January 1st, 2007, actually fall into the first partition, while all other rows in January 1st, 2007 fall into the second partition. The same is true for partition key values of midnight, July 1st, 2007. They end up in the second partition, and everything else greater than January 1st, 2007 fall in the third and final partition. And while this is really subtle, what it points out is that if you're not careful, you can end up with data falling into the partitions that you don't expect them to be in. So there's some alternatives for taking care of this problem. One is to use very specific time values or use range right. Let's take a look at an example of both. First, I can create my partition scheme using very specific time values. Here I've defined it range left, but I've put in very explicit times in order to allow the data to fall into the right partitions. And while this works, I find it a little clumsy. What I prefer to do is define it as range right. Now that'll leave the leftmost partition open, but all the data will fall into the right partition based on the date value, and I don't have to worry about the time. Now, as I said earlier, legacy systems use partition functions using date-time values quite often. It's a common occurrence, so be aware of all these issues. So now let's go take a look at how to build a partition function in SQL Server Management Studio. So here we are in SQL Server Management Studio. We're going to create a partition function using the AdventureWorks 2012 database. And what we're going to do is we're going to create that partition function to divide up our sales table by quarter. And we're going to use date-time column to indicate the partitions. We're going to break it up by quarter, so you can see here the first date that we're using is January 1st, 2007, April 1st, 2007, July 1st, 2007, and finally October 1st, 2007. So those represent the four boundaries. We're going to create this partition using range right. So we will be able to take care of the date-time issue. All of the values for a particular date will fall into the correct partition. And now all we have to do is execute this to create our partition function. So I'm going to run this. It's completed successfully. The way that we can verify that is go over here to our database node, drill down underneath AdventureWorks 2012. Underneath the storage node, we will see partition functions. And here's our sales by quarter partition function that we just created. Very straightforward, very simple. Define whether you want range left or right, place your boundary values, and you have a partition function. So now let's discuss creating a partition scheme. Once you have a partition function defined, that's the next step in the process. We have to define where the partitions will actually live. We have to map those physical locations, and that mapping process is called a partition scheme. Key components of partition schemes are file groups. These are the logical constructs used by SQL Server, and their definitions define one or more physical OS files where the data will actually reside. This encapsulation makes mapping partitions a relatively straightforward process. Some things to keep in mind when you're creating a partition scheme are as follows. Each partition must map to a file group. A single file group can actually contain more than one partition. Each partition could have its own file group. And actually, all partitions could live in a single file group. A key thing, though, to remember is that if you define some extra file groups, this will allow you to add new partitions in the future. It's a lot easier to actually modify how that works if you do so up front. A partition scheme uses only one partition function. We'll come back and we'll discuss this in a little bit, but that's a key thing to remember, that the mapping of where these partitions actually store their data will only use one given function. And the reason that that's important is to take a look at the note here. Multiple partition schemes can use the same partition function. So we can define multiple schemes used by different tables. They could use the same partition function. So the T-SQL create partition scheme statement looks like this. We issue a create partition scheme and we give the partition scheme a name. We assign it a name that makes sense to us. We create that as a partition and we must indicate the partition function name. That partition function must already exist at this point. Then we start listing the file groups. These also must exist, and they could be one or more. They also must exist, and we can have one or more file groups involved. Now, the file group names correspond to the partitions by position, so keep that in mind as you start listing out your file groups. If you use the all keyword, that'll place all partitions on a single file group identified by that file group name. It's possible, but quite honestly, I don't recommend it. So let's take a look at some partition function, partition scheme combinations. Here we have a partition function called example range left PF. It has an integer as its partition key. The data type at least is an integer. We're defining it as range left, and we have boundaries defined as 100, 1,000, 10,000, and 100,000. We're then going to create a partition scheme, and here we have actually multiple examples. We're going to use 3 different types of partition schemes here. We're going to map that partition to our partition function, example range left PF, and we're going to list out a series of file groups. So one example here is in the first row. If we're going to use unique file groups, those file groups you can see are listed there, FG1, 2, 3, 4, and 5. Another possibility, if we take a look at the multiple partitions one file group approach, you can see that we have file group 1 listed twice, which means that the first 2 partitions will map to the same file group, and that's also true for file group 2 in this example. And finally, we finish up with file group 3 at the end. The last row indicates the all keyword, and that means that all of the partitions are mapped to a single file group. Again, I don't recommend this because it's not very flexible. So let's take a look at how we created this partition function, how that mapped to our partition scheme, and how those boundary values fall into the given partitions. So once again, here's our partition function. We defined it as range left with our boundary values. And now we're going to take a look at how those boundary values map out to specific file groups given the examples above. So if we take a look at the partition scheme 1 represented by the unique file groups in the first row, you'll see how those are mapped out. We have a unique file group for every partition, which tends to be the most flexible. In partition scheme 2, you see that we are mapping multiple partitions to a given file group. So the first two partitions live on file group 1, partitions 3 and 4 are on file group 2, and partition 5 is in file group 3. Finally, using the all keyword for partition scheme 3, you can see that they all exist in the first file group. Again, not recommended, but it is possible. If you plan for additional partitions when you define a partition scheme, it'll actually simplify your maintenance tasks later. In the following code, there are more file groups identified than there are partitions. If you remember in our prior example, we had 4 boundary values. That corresponds to 4 partitions. SQL Server will always create one additional partition to take care of any values that fall outside of those boundaries. So that accounts for 5 file groups. And here we have this FG6 defined, which is just going to be there for future use. So what's the benefit? Well, we understand that FG6 is not mapped to any particular partition. It's called unassigned. And because it's unassigned, SQL Server will mark this file group as next used. SQL Server will use the next used file group to store data for partitions that you add in the future. So here's a tip. For greater flexibility and performance gains, always consider assigning a different file group to each partition defined by a partition function, and in addition, add more file groups than partitions, because it'll make the maintenance task of adding partitions easier in the future. So let's go to SQL Server Management Studio and take a look at some demos. Here we are in SQL Server Management Studio, and in this example, we're going to add the file groups needed to support our partitioning scheme. You'll see here that we are basically going to have 4 file groups. These are logical names assigned to each of the 4 quarters of the year that we're interested in partitioning, which is 2007. You'll also notice that up at the top here, we are adding a file group for anything that falls earlier than the year that we're interested in. So anything in 2006 or earlier will also be taken care of. And down here at the bottom, we're doing the same for anything after 2007. So anything 2008 and greater will move into that partition. And the reason for that is, once again, we have to make sure that we accommodate all of the values within the domain. And so when we're considering our order date as the piece of data that defines where our data will fall in the partitions, we know certainly that there are dates before 2007 and after 2007. So we're just going to accommodate those. And all I have to do here is execute this code to actually create those logical file groups. So we're going to do that. And that completed successfully. The next step, I close this particular example, is I have these file groups defined logically, but now I have to indicate where physically they're going to reside. And here you can see we're using the alter database statement to do that for each of the file groups we just created. We're going to map those to individual NDF files that SQL will then store the data in. So all I need to do here is execute this code, which will create a physical file that will associate it to a particular file group. So let's go back up to the top here and execute these statements. And we now have a set of file groups defined. We have not only the logical definition, but we have the physical files created. And now we're able to actually create a partition scheme that will take advantage of those file groups. And so here we're going through the process of creating that partition scheme. We will do a create partition scheme. We give it a name. We're telling it what partition function to use. And then here are the mappings. You'll see that we're doing a 1-for-1. Remember, we're interested in the sales year 2007, and we defined this partition as range right. So here is quarter 1, quarter 2, quarter 3, and quarter 4 right there. But because we have to accommodate all of the values, we have a partition defined for anything earlier than 2007 and a partition defined for anything greater than 2007. So we'll go ahead and execute this. And you'll notice the little message that we get. Sales by quarter PS, partition scheme, has been created successfully. But then notice this here at the end. The last one out here didn't map to any values. And so it is marked as next used. So we're prepared for handling additional partitions in the future just by including or defining more file groups than are needed. If we go over here to verify how we're doing, go to our AdventureWorks database, again drill down underneath storage. Here are our partition schemes, and there's the sales by quarter partition scheme we just created. Pretty straightforward. So now we understand that partition functions outline how we're going to organize our data. The partition schemes describe exactly where to store that data. And once we've defined that, we can actually create a partition table or index. To create a partition table or index, you use the create table or create index statement. In both cases, the statement has to identify the partition scheme used to map partitions to file groups. The table column to use as the partitioning key also needs to be there, and it has to match the data type, length, and precision of the column used in the partition function you defined. A simplified version of the create table statement demonstrates what I just talked about. We're going to create a table, and obviously we give it a name, followed by its column definitions. The difference here is then we indicate what partition scheme we're going to use by using an on partition scheme name, the name of an existing partition scheme, and then in parentheses we have to indicate which column within the table that we're creating should be used as the partitioning key. And remember, we have to make sure that it's of the same data type. So here we have our create table, example table. We have two simple columns, and we're going to use a fictitious example PS1 partition scheme that takes as its partitioning key an integer, and that's going to align in our example here with column 1. Creating a partitioned index is very much the same. We have to use the create index statement, and we have to indicate what partition scheme and partition key to use. So here you can see we're creating a non-clustered index. We're going to create it on the example table we just created, and we're going to put it on the second column. That takes care of the index piece. But because we are indexing a partition table, we have to indicate what partition scheme to align this to. And in this case, it is the partition scheme example PS1. And we once again indicate the partition key, which in the case of this table was the integer column 1, and we are all set to go. So let's take a look at how we do this in SQL Server Management Studio. So here we are in SQL Server Management Studio, and we're finally ready to create our partition table. You can see that we're using the create table statement, and we are creating the columns, defining the columns that will be a part of that table. Everything so far looks very standard, very straightforward. What is different is down here at the bottom we're indicating which partition scheme we want to create this table on. And we are going to indicate that we want to create it on the sales by quarter PS partition scheme, which we can see over here is the partition scheme we created just a little bit earlier. And we also need to indicate what's the partitioning key that we're going to use. What is the column defined within this table that should be used to define our partitions, the boundaries. So here is the order date column. That is the column defined as date time, which will provide the values used to partition our table. So everything's in order, and we should be able to just simply execute this and create the table. And that was completely successful. And so we have a table created. So let's take a look at a few other things that you can do with this table while we're here. One of the things that we could do is to apply a check constraint. I talked about this a little bit earlier, but the reason that we might want to do this is to make sure that only values that we're looking for actually end up in the table. So for this particular example, we're going to apply a constraint on the order date, and we're going to indicate that anything greater than or equal to January 1st, 2007 and less than January 1st, 2008 is acceptable. Anything outside of those ranges we're going to reject. This helps us to protect that partition table a little bit, and we will only get in the partitions the data that we expect. So I'm going to add that constraint to our table right now. And that was completed successfully. So now we have a partitioned table along with a check constraint so that our data will be correct. And now we're going to take a look at applying an index to that partition table. Here you can see we're going to add a primary key constraint, an index, to our table, and we're going to use the alter table statement again to do that. And the thing to point out here is, once again, we are indicating what partition scheme to use and what the partitioning key is. So we'll go ahead and apply that so that we have our primary key defined. And that is completely taken care of and okay. And finally, what we can look at here is now it's time to load some data into that table. And what I'm going to do here is we're actually loading some data from an existing table within the AdventureWorks database. So we're kind of taking some sales records from the existing database and loading them into the partition table we just created. And I want to preserve the identity values used there so that we can make some comparisons later. So you'll see here that I'm actually going to allow the identities that exist to be inserted by using the set identity insert to on prior to doing our load of data. And after we're done loading that data, I will actually turn that back off. So all it's going to do in between these set identity inserts on and off is insert data from the existing sales order header table into our new sales order header partition table. So let's go ahead and execute that, and we should get some rows loaded. One of the things to point out here before we do that, though, is notice that we're pulling a very specific date range. Even though we have a check constraint on the table, we've decided to add the date ranges here just to be very clear and consistent. So let me go ahead and load that and see what we get. And we have roughly 12,500 rows partitioned, loaded into that table, and ready for us to use.